Hello? Hi there. Okay, micro frontends. Working as a web developer in the last years is quite exciting. So technology, the stuff we are working with from day to day is rapidly changing. Browsers are changing, but also the tools we use are changing. So I've plotted a simple timeline on popular libraries and frameworks over the last 12 years, from prototype to React or Vue.js right now. And I think it's safe to assume that this trend wouldn't end today. So this will continue on. Things will change further. And yet we are quite comfortable on building bigger and bigger front-end applications that rely on one single framework. And after a certain size, the framework or the application gets so large that one developer is not able to wrap his head around it. And this is typically when things get hard to maintain and things get hard to work with. So we as a community have a problem, and yeah, not a tasty one. And in my talk, I will show you an alternative way on building software. So who am I? I'm Michael. I work as a front-end developer at Neuland Bremen GmbH, which is a company from Germany which works with large e-commerce, with large retail companies, and we build their e-commerce platforms and help them to grow and get into the digital world. The company is based in Bremen. This is located in the northern part of Germany, and if you're not familiar with Bremen, you might have heard of the Bremer Stadtmusikanten or Bremen's town musicians. This is where this fairy tale comes from. So, micro frontends. It's a buzzwordy term. We have microservices and frontends and micro frontends, whatever. This is quite a new term. The concepts I will be describing today are not that new. So in the past, they went by names like verticalized teams, self-contained systems, or vertical decomposition with UI composition. So long terms that aren't quite as catchy as micro frontends. And these terms look at the same type of architecture, but from a different angle. And with microservices, we'll look at it from a front-end first or modern front-end development perspective. So first part of the talk will be organizational. So we'll talk about architecture, how to organize your teams. We at Neuland use this architecture on 3 major clients, with ranging from 10 to 60 developers per customer or per client. But we're not the only one. So other large companies, European companies like Otto, Zalando, or Autoscout are using it. But also Amazon operates like this. And one quick remark. This is not a silver bullet. This might not fit for your company, but it might be a good idea to look at the problems this architecture is trying to solve. Okay, this is how a classical web application was built 10 years ago. You have a handful of developers working on one team. Somewhere in the project, there's one folder with all the browser stuff, so templates, and one big CSS file, and jQuery plugins, and whatever. And over time, this changed. So the concept of a front-end developer emerged. So someone who's interested in building good UI, someone who's willing to learn how to talk to browsers, how to make good software for browsers. And when teams got even bigger, the backend people ran into an issue, a scaling issue. So the term monolith or backend monolith came up, and they had a problem. So adding more people to the team wouldn't increase the speed, wouldn't get more output, more productivity. Things got frustrating and hard to maintain. And the popular solution nowadays is to use microservices. So break up the big backend application and cut out small microservices that are all centered around one topic. So for example, payment processing, or handling media, or dealing with product data, for example. And the front end usually didn't change. One thing that was introduced to make the front end work with this architecture is most of the time you introduce some kind of an API gateway, so the front end doesn't have to know about how to deal with this complex microservices architecture underneath it. And there are different approaches. There's even a way of automating this kind of API layer with GraphQL, for example. But this architecture still has a few problems, and I will highlight 3 of them. The first one, the most obvious one, because I've introduced it this way, is the front-end monolith. We have a scaling concept for the backend, but we don't have a scaling concept for the front-end. And yes, we could do the same thing the backend guys did in the front-end independently, but this does not sound like a good idea. Next problem is when you now want to add a new feature, when the product owner wants to add virtual reality images, models, whatever, into the platform, they typically have to talk to more than one team. So they have to talk to the media team, they have to talk to the product team, they have to talk to the API gateway and the front-end team who should display it to the customer. And if you ever worked in a setup with more than one team, you know that communicating between teams, getting all on the same, all developers on the same page, is a quite hard thing. And most of the time, this is spent in communication, in agreeing on things, and not on being productive. And this is a slow and a very frustrating process for all of the people that are in this process. Okay, next one. Now we've added the customer to the picture. And when we look at this, it quite looks like a layer cake. So we have the customer, we have the front-end people who are quite close to the customer, we have this gateway, and we have the backend people. But the job of the backend people, of the media people, for example, is not deliver value to the customer, but their main job is deliver an API to a specification, for example. And this is a problem because, as we've heard yesterday from Daniel, that ownership and being able to relate to your product, to the thing that brings you money, is very important for everyone to be motivated. Another thing this architecture promotes is having technical teams. So having teams centered around one specific technology. You have front-end people working together, you have back-end specialists in whatever, in hosting images working together. And this is great when you want to become a specialist in a technology, but it's not great if you're creating good thing for the customer. So an alternative is to not group your developers or your people around a technical thing, but group them around a use case. Something, so help them to solve a customer need, for example. And in this example, we have a cross-functional team. So we have a team with a front-end developer, a back-end developer, specialists in different areas, maybe ops guys, but also business people who know what to build and what's the best thing to build here. And now, what are use cases? It's quite a broad term. This is an example of use cases in e-commerce. So we work in e-commerce, so my examples on the next slide will be e-commerce. And in e-commerce, there are multiple stages of the customer by being in your shop. One thing is he gets into your shop because he wants to buy something, but he doesn't quite know what. So he wants to shop around, wants to look around, so you have to inspire him. He wants to get inspired. When he's made a decision, maybe he has one or two products before him, he wants to make an informed buying decision. So you have to provide him with information on the product. And when he has decided to really check out this product, this process should be as easy as possible. So paying the thing and getting out. Okay, we saw this before. This is a classical microservices architecture. And with the microservices or verticalized team model, the solution looks like this. So we saw these microservices now forming into larger blocks, and all of these blocks include front-end and are run by independent and cross-functional teams, so teams with all professions in one team. And the special thing is every team has one specific mission. So you have, for example, a checkout team, and the checkout team's responsibility is to make it as easy as possible to check out a product. A really nice thing with this concept is that this team doesn't have to worry about other things, like hosting images or like doing SEO or building a good product search, for example. And what this concept gives you is you get team isolation. So every team you see here has its own stack, can choose its own technology, can work on their own schedule and deploy on their own schedule. So they are not connected and don't have to synchronize because the cuts you make and the groups you make should align to the features you want to implement. So let's get into a real-world example. This is a typical product page. You have different kind of tractors you can choose from by clicking on the images. You get recommendations for each tractor. You can click the buy button and add something to the mini basket on the top of the page. In this model, this complete page, including the head and the body, so the whole page is delivered by the decide team, the team in the middle from the slide before. And this team includes a fragment, so a piece of software, a little rectangle fragment from the Inspire team. And the nice thing is that the decide team who runs the page doesn't have to know anything about this fragment. It just has to include it. And the same goes for the checkout team. So you have the buy button and you have the mini basket button, and team decide just has to implement them, and how pricing works, how calculating basket works is something that is done by the checkout team. Okay, so now how to integrate. We saw this on a picture, but we haven't seen it in code yet. One thing we wanted for our solution is to have a neutral abstraction. So team A shouldn't know which front-end technology, which front-end stack team B or C is using. So we needed in a neutral component model. And as Jill pointed out before, there is something that was promised by the standards consortiums a few years ago, and yeah, it's this guy. Who of you is using custom elements in production? Okay, a few hands. Custom elements is in a broad term, an umbrella term. So it consists of HTML imports, HTML templates, custom elements, and shadow DOM. And these are not all ready for production yet, but custom elements is quite solid. Custom elements is this feature that lets you define, as a developer, a custom HTML tag in the browser. So you can make up a name, put a hyphen in it. This is the only requirement the spec gives you to maintain forward compatibility. And then you're good to go. And you can attach code to this HTML tag. So every time the browser comes across one of these HTML tags, your JavaScript code gets called, and you can do things like render something inside of you. And this would look like this. So you can call custom element.define, provide the name of the HTML tag you want to register, and then provide an ES6 class. And everything the ES6 class has to it has to extend from HTML element, and you don't have to provide any functions, but you should, otherwise it's quite meaningless. The connected callback function, for example, is called when your element is found in the DOM or is attached to the DOM. And this is the place where your software solution of choice now comes in. You can choose to use plain HTML. I like tag template strings, for example, but you can also pull in React or whatever framework of choice here. And in addition to connected callbacks, there are also a few other lifecycle methods that are provided. So you get the disconnected callback, which gets called before your element is removed from the DOM or shortly after it's removed from the DOM. And you can run code like freeing up memory or detaching event listeners, for example. And an interesting one is the attribute changed callback, which notifies you when someone changed an attribute, like when you're in a React application, when someone toggles a prop, for example. Okay, browser support. Browser support is quite good. The custom elements v1 standard stabilized end of 2016. In Firefox, it's available behind the feature flag. In EA's, in Microsoft Edge, It's under consideration. And there's a very solid polyfill available, which uses the mutation observer API, which is available in all of these browsers. So there's no hacky DOM watching or whatever going on behind the scenes. And yeah, you get notified when your element enters the DOM, even in IE 11. And this doesn't make problems in our solutions. OK, this is how the example from before now looks like in code. So we have these fragment blocks, and they are essentially a custom element, which the red team has to include. And everything that goes on inside of this custom element is not the concern of the team who's delivering the page. Now with interaction. So when the user clicks on the green tractor, everything the red team who owns the page has to do is to toggle the SKU property. So go from red to green, and everything is fine. So each fragment gets a call, can render, can update itself, and then go on. With this solution, essentially, the DOM becomes the API between your teams. You don't have to make up a new API. You can just use the DOM. You have to provide the tag name of the custom element. You have to define the attributes that can be used with your fragment. And you can define events like someone has added something to the buy button. Maybe your buy button should emit something was added to the basket event, for example. OK, framework support. So how do frameworks, modern frameworks like Vue or React or whatever, play together with using custom elements inside of them? Most of them do a really good job. Vue, for example, their custom elements are a primary building block. And even in other frameworks like React, it works quite good. Rob Dadson from Google has put together an interoperability test suite. You can see it at custom elements everywhere, and you can see which framework still has issues when talking to custom elements, for example. OK, the escalator. Up until now, we've only talked about perfect worlds. So we are on a page, every JavaScript has been loaded, but when we are building something, when we're building applications for the web, for the open web, most of the times we can't rely on all devices being fast, on having low latency. So we have to model our site so that it's also usable without JavaScript being active or being executed yet. So our site should be useful without JavaScript. Maybe it is not as fancy without JavaScript, but it should work. OK, progressive enhancement. Yes, this is the solution. But sadly, the web standards don't have any solution for universal custom elements, for example, or universal web components. So the spec is only concerned with what goes on inside of a browser. But we know how to build universal applications, and it's easy for us to build universal fragments, for example. We can just call the same render function on the browser and on the server. We can make up a URL on the server which delivers the initial HTML of a fragment, for example. But when we have that, we now have to integrate, for the first load of the page, these fragments all in one page. So our inner HTML comes with all fragments HTML on the first load. And technology we are using is called server-side includes. So you basically add an HTML comment to your template, and this one will get executed by the web server and replaced with the actual content behind this URL. And if SSI sounds familiar to you, it might be because it's a really, really ancient technology. This is an excerpt from a book from 2001, back when executing JavaScript was called DHTML. And I'll just read out the thing. The easiest way to import external content into a web page is to use server-side include. And this technology existed in web servers before and still exists in most modern web servers. And this is a very simple but extremely solid technology. And custom elements and SSI includes build a perfect couple, so they partner up very nicely. You can use the SSI include for the initial render, and the custom element picks it up from there when the code is loaded in the browser. Okay, so this is how our page now looks like. So instead of writing empty custom elements, we now have an SSI include in every element, and we see the SKU property maps to a URL parameter, for example. Okay, so up until now, we've only talked about static pages or pages and how to integrate things on pages. But a typical website consists of more than one page. And so we need a solution for going from page to page. In a scenario with two teams, for example, each team building multiple pages, the easiest way is that each team can handle client-side transitions on their own. So if you move from the list page to the product page, which are both are maintained by team A, you get soft navigation, so client-rendered fast transitions. And when you cross team boundaries, so go from the product page to the cart page, for example, you get a hard navigation, the browser reloads, and you initially load the cart page, for example, and then move on with soft navigations. This concept is a very easy concept, but the drawback is with increasing number of teams, you increase the number of hard navigations and your user experience will not get better. So this is an alternative. In this alternative, each team does not deliver the complete HTML page with head and body, but each team will provide some kind of page fragment, so a page level fragment, which includes these other fragments we saw before, for example. And you have an HTML shell, so a common HTML for all pages, which is essentially is black but contains client-side and server-side router, so a universal router. And you have a centralized mapping where you say this URL maps to this page level fragment, for example. This works great, but the drawback is that with this solution we need common code. So we have shared code between all of the teams. And when we want to change something in this code, we have to talk to all teams. This may be fine, but you should think about this. Okay, the last part. Things we've learned over the last 4 years on working in this architecture. First one, I've talked about it, use the browser API. It's quite tempting to come up with a meta framework which solves all kind of problems that all teams have and have a unified place where all these problems are solved. But try to avoid it. Try to maintain team independence as strong as possible and try to avoid using shared code. So with our shared code you essentially couple this team. So if you have a central React.js file everyone is using, you can never change this React.js file without having to talk to all teams and coordinating all teams to upgrading on the same day, whatever. You don't want this. Isolate teams. So yeah, like I said before, don't share code, don't share runtime, don't build a big outer React applications where each team just delivers a component. Deliver a system where each fragment can live on their own and are not tied to outer technology. And don't share state or global variables. Talk to your neighbors. You gain independence with this model, but one thing that comes with it is that you have front-end developers working in different teams side by side, and they might come across similar problems. So it's important to talk to each other. Pack light, so use the best tool for your job. If you're building a very small thing, maybe you don't need to include all of Angular and whatever. Register your custom elements as soon as possible and download the necessary code only when the user needs it. So you can register immediately, but lazy load or code split your code so that it's only loaded when the user really comes across it. Measure performance, a very important one. Luckily, HTTP2 solves a whole bunch of problems. So Before, it was best practice to bundle up all your JavaScript in one single file, and this wouldn't work great with this verticalized model where each team should deliver their own assets from their own service. With HTTP 2, this is not a problem anymore. So loading multiple JavaScript files in parallel, in most cases, is even better. And you should measure, you should know your numbers, you should optimize, but you shouldn't over-optimize, and you should always value team independence. Ownership is important, so the obvious one is every piece of software you create should have an owner, or a team which is responsible. But since we share a runtime, so all our code runs in the same browser, it's quite important that in the areas where we can't isolate on a technical level, we use prefixes, for example. So when we add CSS classes, we should prefix our CSS classes with the team name. And same goes for events that you're firing or cookies. So when someone looks at some piece of code, it should be obvious which team he should talk to when there's a problem. And yeah, have a design system. So having a style guide, having a pattern library that every team can choose to use is a good thing in this example. Don't include your pattern library globally, so everyone is forced to use the same version. Try to deliver it as a library like Material UI, for example, which each team can pull in the version they want, and they can upgrade on their own pace. Okay, I think we've come to the end. Thanks for listening. If you want to know more about this topic, you can go to microfrontends.org. I've written up things I've said here today. There's also running code. And I've one extra slide I've previously had in the beginning of the talk, but many people told me to not put it in the beginning of the talk because it has the potential to derail the whole talk. So this is a slide.
Michael Geers, ladies and gentlemen.